Okay, we're going to look at the connection between rational exponents and roots and surds. And let's just get started. In the last video before this one, we looked at 8 to the 2/3 power, that we could take 8 and make it 2 cubed, and then raising a power to a power, 3 times 2 over 3. Threes would cancel, we'd have 2 squared, and it would equal 4. But what if we looked at this little 3 that's on the bottom in a different way? It turns out that that little 3 is really the root, the cubed root, and 8 is squared. So the cubed root of 8 squared would be the cubed root of 64. And hey, the cubed root of 64 is 4. 4 times 4 times 4 is 64. So it turns out that 8 to the 2 over 3 is equal to the cubed root of 8 squared. Okay, so those things are both the same thing. That means we could come up with a general formula that if we have anything to the m over n power, it's the nth root of a to the m. Well, that's a root definition. That's what it is. So a rational exponent is really a root. Okay, that's how it works. Now we've got some examples here. Say you have the cubed root of a squared. Well, it's the same as a to the 2 over 3 because the root part is the fraction there. The square root of x is really, there's really a 2 there. It's x to the 1 over 2. That's where the square root sits in the denominator of the rational exponent. So a to the 2 over 5 is the fifth root of a squared. So there's the root, the little number at the bottom, and the 2 on top. So this must be the cubed root of x, and it's to the 4th power. So they're just different ways of looking at exactly the same thing. We can get questions that get a little bit more involved. When you see 625, it's really kind of good if you knew that it was a power of 5. First, so that's writing it as 5 to the 4th power. 81 is really 3 to the 4th power. But there's this whole thing is put to the power of 3, but the root goes in the bottom. So it's really 5 to the 4th and 3 to the 4th, all to the 3 over 4 power. Well, we take this 4, we multiply it by 3 over 4. The 4's cancel, and you just get 5 cubed. Same thing happens on the bottom, 3 to the 4th. To the 3 over 4 power, the 4's cancel, you get 3 cubed. And 5 cubed is 125, 3 cubed is 27. That's example 3. Let's look at another example. We won't be free. Let's look at example 4. Well, this whole thing, the cubed root is really that denominator put to that power. This 3 and 3/8, well, that's 24 plus 3. It's really 27 over 8. Now, they choose numbers like that because that's 3 cubed over 2 cubed. Now you can take all these powers. This y to the minus 6 is really 1 over y to the positive 6. That's what a negative exponent is about. Now all you do is take this 3 and the 12 and the 3 and the 6 and multiply it by 2 over 3. Well, the 3's cancel all over the place. You get 3 squared, x to the 24 divided by 3 is 8. The 3's cancel, 2 squared. 6 times 2 divided by 3, 12 divided by 3 is 4. 3 squared is 9, 2 squared is 4. There's your final answer. Okay, well, we're going to do some questions, a whole bunch of questions on this kind of stuff, just to see how good you are at it. And good luck with it all.